Dengue, Zika, chikungunya. Every year, they infect hundreds of millions of people, and for not one of them is there an approved antiviral drug. But every virus has an Achilles heel. Aquiles finds it. These viruses mutate fast, so drugs that attack them head-on stop working, and the hunt for new targets is slow, manual, and buried in millions of papers and databases. Aquiles changes that. A virus cannot reproduce on its own. It hijacks dozens of your own human proteins. The machinery it cannot live without, so instead of chasing the virus, Aquiles hunts those human proteins, the ones that are both essential to the virus and hittable by a drug. And because the target is your own biology, the virus cannot simply mutate around it. A host-directed drug is far harder to escape, and a single target can work across dengue, Zika, and chikungunya at once. Here is how it works. A specialist agent, powered by Claude, reads the evidence, drug databases, protein interaction maps, and the published literature. Then it makes concrete, checkable claims about each target. But here is what makes Aquiles different. The AI does not get to grade its own homework. A second, independent verifier re-rates every single claim in isolation and checks it against the raw database record, confirmed, corrected, or rejected. And it matters. Across the current target set, that independent verifier caught 68 of 111 claims, 61%, as unsupported or wrong. A model checking itself would have delivered every one of them as fact. The result is a ranked landscape of human antiviral targets, and every score is computed in code from verified evidence, druggability on one axis, strength of evidence on the other, and the size of each bubble is how many drugs already exist. Open any target and you get an auditable dossier, a clear go, watch, or no-go call, the mechanism of action, why past trials failed, and the exact experiment to run next. And when an approved or clinical stage drug already hits that target, Aquiles surfaces it as a repurposing opportunity, like CB5083 for VCP, a shortcut from discovery to something you could actually put in a dish. Every claim traces back to its source. Here, the verifier confirmed that VCP is druggable, corrected the drug's exact interaction score, and rejected a claim the raw record simply did not support. Nothing hidden, nothing assumed. And you do not need to be a bioinformatician. Just ask in plain English. Claude plans the work, runs the verified pipeline live, and answers you with every tool call and every citation shown as it happens. Everything is built on public peer-reviewed data, open targets, DGIdb, Europe PMC, and published CRISPR and interactome studies, human in the loop, and fully transparent. Aquiles, find the target a virus cannot live without, and trust the evidence because an independent AI already checked it, built with Claude.